Suppose a function satisfies these two partial derivatives, and also you know that x is equal to t and y is 2 sine t. Compute df dt when t is 0. Okay, let's see what this means. F is a function of x and y, right? And x and y are both functions of t. Now, therefore, if you change the value of t, that's going to affect f in two different ways. T will change the value of x, and if x value changes, of course, f will change, right? Also, changing t will change the value of y, and that's also going to change the value of f. In real world, the chain rule, multivariable chain rule, gets used a lot in economics because a lot of things in real world happens to be affected in multiple ways. So, for example, F is, say, the price of wheat. Well, the price of wheat would depend on the price of oil. If oil increases, then price of wheat will increase, right? But it might do in many different ways. One is if oil price goes up, then X is like the operating cost that goes up, and therefore wheat price will go up. But it's also true that if the oil price goes up, then the transportation cost, let's say Y is transportation, that will also affect F so that it goes up. So if you want to measure how F is going to increase when you increase the oil price, then you actually have to measure how F gets affected through this and also this, and you have to add them up. That is what multivariable chain rule is saying. It says if you want to know how F changes when you change t, after all, this is the meaning of this is rate of change of F with respect to the change of t, right? And this is same as partial of f partial of x times dx dt. So this measures, dx dt measures how x changes when you change t, and you multiply that by how f changes when you change x, and the product of the two measures how change of t is going to affect f through x, okay? Plus change of f over change of y times change of y over change of t. In the same way, it calculates this one, and you add them, and this is the total change of f with respect to t. Okay, so if you know this, then since you're given round f round x and round f round y, we can now say df dt is 3x plus 2y times, what's dx dt? Let's calculate this. If x is e to the t, then dx dt means you're differentiating e to the t, but that's same as e to the t, right? And what about dy dt? dy dt would be differentiating this by t, so it's 2 cosine t. So equipped with this knowledge, you can now replace dx dt by e to the t plus 2x minus y times 2 times cosine of t. Okay, so we're almost there. Now we have to figure out what df dt is when t is equal to 0. That means you're plugging in 0 into t, so you get 3x plus 2y e to the 0 plus 2x minus y 2 cosine 0. Now cosine 0 and e to the 0 are both 1. Oh, but also if t is 0, x when t is 0 is e to the 0th power, so it's 1, right? On the other hand, y when t is 0, that's 2 times sine of 0, that's just 0. So x and y will also give you the values. This will be 1 and this will be 0. So those have to be also calculated. So you get 3 times 1 plus 0, e to 0 is 1, 2 times 1 minus 0, and cosine 0 is 1, so it's just 2. So you get 3 times 1, which is 3, 2 times 2, which is 4. Adding them together, you get 7. Okay, So that's how you use the chain rule to compute the total rate of change of f with respect to t.